distance is 0. What is the definition? Mod of x minus 2y1 is equal to 0. But mod is 0 if and only if x minus 2y1 is equals to 0. That is equals to if and only if x is equals to 2y1. But which is not same as, which is not exactly equals to y1. Right? Which is not exactly equals to, of course, in fact, which is not exactly equals to y1, which is not x2 not equals to, may not be equals to, not equals to y1. I don't know whether x2 equals to y2 or not. I don't know about this information. No information about this. I don't know about this. So we can easily conclude, this is my guess. Now we can give a counter. This is my guess. Right? So suppose I am going to take what I do. Suppose x is equals to 1, 0. Y is equals to, right? Or 2, you can take 2. This is 1, 0. Right? So therefore, what happens? X1 is equals to 2y1. So satisfies. X1 is equal, this is x1, this is y1. X1 is equals to 2y1. Here, so clearly x not equals to y. But what about the distance? Distance between x and y is equals to modulus of x1 minus 2 into y1. That means 2 minus 2. That means 0. Therefore, distance is 0, but the points are different. Therefore, it cannot be a metric. So first you need to guess it, then you solve it. Suppose you can take this idea, d2 is equals to x comma y. This, only this, x1 minus y1. Is it a metric? What is my x? X is same, x1 comma x2, y is equals to y1 comma y2. So again, there is no problem with non-negative because modulus is there. The problem with only second condition and triangle inequality. So what is this? Actually, this is 0 if and only if mod of x1 minus y1 is 0. That means x1 minus y1 is 0. That means x1 is equals to y1. That means I don't know information about x2, y2. Yes or no? I don't know information about x2, y2. Now what I do is that I can take x is equals to 1 comma 0 or 1 comma 2. Right? 1 comma 0, nothing else. మీరు ఇక్కడ ఏది తీసుకున్న పని చేస్తుంది ఎందుకంటే మీ ఇష్టం అనేది రాసుకోవచ్చు. Right? Y is equals to 1 comma something 2. So x1 is equals to 1, 1 is here. So clearly x not equals to y. But what about x2? Distance between x2 comma y? So that is same as saying that modulus of x1 minus y1. That is equals to 0. So distance 0, but the points are different. Right? Therefore, it cannot be a metric. Suppose d3 of x comma y is equals to mod of x1 minus y1 plus x2 minus y2. Is it a metric? So this is x is equals to what is the same, x1 comma x2, y is equals to y1 comma y2. Right? So same thing, distance is always non-negative because mod is there. Distance is non-negative and distance is 0, second condition. That if and only this is x1 minus y1, 2 minus y2. So the thing is actually sum of this is non-negative, this is non-negative. Sum of two non-negative numbers equals to 0 if and only if each number is 0. Each member is 0. So modulus is 0, each of the term is 0. That is exactly equals to x1 is equals to y1 and x2 is equals to y2. That is x1 is equals to x1 is equals to y1, x2 equals to y2 means what? X equals to y. Right? This is a redundant idea, so it satisfies second property. And D3 is always symmetric because modulus is there, very strong condition. Is x1 minus y1 plus x2 minus y2. Right? So therefore, that is equals to y1 minus x1 plus y2 minus x2. Because modulus is there, mod of x is equals to mod of minus x. Is exactly same as saying that distance between y comma x. So distance satisfies symmetric property. Distance satisfies symmetric property. Right? What about triangle inequality? How many points do I require for triangle inequality? 3 points. So this is exactly what? X1 minus y1 plus x2 minus y2. Again using concat technique, adding and subtracting. Concat technique. So use this modulus of the sum less than or equals to sum of modulus by triangle inequality in real numbers. Right, this join this and this. Join this and this. Is exactly degree of comma y. Therefore, it satisfies triangle inequality. Therefore, it is a metric. So D3 is a metric. This is called as L1 metric. On R2. Understand this? This is a metric. We can call this metric as L1 metric. So very standard metric actually. In fact, every metric is very, very important because we're going to read again and again this metric properties in different orientations, different definitions, like open set, closed set. Right? Keep in this. So fourth one. D4 of x comma y is equals to maximum of mod of x1 minus y1, x2 minus 1. So this is also metric. You can easily check it by the same strategy. Right? Distance is non-negative because this is non-negative, this is non-negative. Therefore, distance between x comma y is non-negative and it satisfies second property. Distance between x comma y equals to 0 if only if x equals to the same idea. And distance satisfies symmetric property. Right? So we need to know the triangle inequality. That is important. For this, I can take two elements. Right? So I'm going to start with x1 minus y1. What is this? X1 minus z1 plus z1 minus y1. But this is exactly same as saying that x1 minus z1 plus z1 minus y1. But this exactly does not equals to maximum of x1 minus z1 comma x2 minus z2 plus this term less than or equals to maximum of z1 minus y1, right? X1 minus z1. All right. Sorry, x2 minus z2. What is this? This is exactly, you can write this as one term, keep it as it is. This is exactly z2 minus, right? Right. So this is exactly what actually is exactly what distance between x comma z. This is nothing but distance under here for distance d4 of z comma y. Therefore, this term is less than or equals to this. Similarly, one can prove it. Distance between, see, if I consider this term, I'm going to get this. If you consider this term, the same one, less than or equals to this x comma z comma. So by using this, right, by using this for the set, which is set for the set x1 y1 x2 minus y2, for the set this is an upper bound. Which one is an upper bound? This one is an upper bound. For the set which this one is an upper bound, therefore upper bound is a great, once it is an upper bound for the set, so this set has a greatest upper bound, greatest No. What is that? Least upper bound. Because it's an upper bound for the set, it has a least upper bound. That is what actually is supremum. Therefore, the supremum, which is a finite set, supremum has a maximum. Because it's a finite set, that supremum has a maximum. Therefore, this maximum is always less than or equals to this. Is it clear? This is an upper bound over there. Therefore, it has an infimum. Infimum means infimum among upper bounds, least upper bound. Therefore, that least upper bound for the finite set. Finite set is compact. Therefore, automatically it has a maximum. But what is this exactly? D of x comma y. Therefore, it satisfies triangle inequality, right? Hence, it is a metric. So this metric is known as Shailaja G metric. This is called as Shailaja G metric. Okay. Similarly, you can check. Fifth one. This is also standard metric. Distance between 2 points. Suppose you have a point here, x1, x2. This is my point y1, y2. This Euclidean distance. Under root of x1 minus y1 whole square, y2 minus x2 minus y2 whole square. I equals to 1 to 1. Y equals to 1 to 2. x1 minus yi modulus whole square. Whole square whole power 1 by 2. For x equals to this, y equals to this. So this is also a metric. You can easily check it. It is always a metric, right? So distance always non-negative. You can check these properties. This is modulus is there. The distance is 0 if only if the points are same. And distance satisfies symmetry property because modulus is there. You can. So what about triangle inequality? See, this is by Minkowski inequality. When you go through the function analysis, you know it. What is this? Summation I equals to 1 to 2 xi minus yi whole square whole power 1 by 2. Again, adding and subtracting technique. This is nothing but I equals to 1 to 2 xi minus zi plus zi minus yi whole square whole power 1 by 2. So just keep in mind, this is my Minkowski inequality in R power n. In R power n. Summation I equals to 1 to n xi yi whole power p whole power 1 by p less than or equals to summation I equals to 1 to n xi whole power p 1 by p summation I equals to 1 to 1 modulus of this whole power 1 by p, where x is equals to x1, x2, xn, y is equals to y1, y2, yn. Sequence of scalars or sequence of real numbers, we can take anything. And p is a number which lies between 1 to infinity, where p is a number which lies between 1 to infinity. So whenever is there, here p equals to 2, bigger than 1, therefore satisfy this. So this is a number by Minkowski inequality. Summation I equals to 1 to 2 xi minus zi whole power p. P means 2 whole square whole power 1 by 2 plus summation I equals to 1 to 2 zi minus yi whole square whole power 1 by 2. This is exactly what d phi of x comma z plus z comma y. So hence it satisfies triangle inequality, hence it is a metric. This is exactly what Euclidean metric or usual metric. Metric on R2. This metric is what? Actually usual metric or standard metric or Euclidean metric, because Euclidean distance is there. On R2. Similarly, you can extend the idea to r power n also, right? So this is about r power 2. You can extend this idea to r power n, same. Okay, I'm not going to tell this r power n. You can extend this idea to, see what I'm doing. We are first reading, we studied about r, then we extend this idea to r power 2. Similarly, we can extend this idea to sequences. Right? Problem number what? This is problem number 1. Next, I'm going to tell you problem number 2. You can extend this idea to sequences. Suppose 1 less than or equals to p less than infinity. Suppose my LP is the sequence or space of all sequences which are p to summable sequences. Xi, this convergent series. Set of all sequences in such a way that which are p to summable sequences. In fact, you need, so in order to understand this idea in clearly, what you know is that suppose p, if you take p equals to 1, what happens? This is what L1. L1 is nothing but what? Set of all sequences, 1 to summable sequences. That means what? Set of all sequences. This is convergent series. Means what? The sequence is absolutely convergent. Understand what is this? Set of all absolutely convergent, because modulus of xi is convergent. Set of all absolutely convergency. Absolutely convergent sequences. Suppose you take this. Is it absolutely convergent sequence? Yes. Because by p-test it is convergent. Suppose I'm going to take 1 by 2 square, 1 by 3 square. This is my sequence. Is it absolutely convergent? Yes. Summation x I equals to 1 to infinity, xi is nothing but summation I equals to 1 to infinity. What is xi? 1 by I square modulus. But I square is always positive. No need to take modulus. This is by p-test is convergent. So this is absolutely convergent. Hence it is an element of L1. Understand? So this is my L1. Similarly, you can extend this idea to for p equals to 2. So set of all square summable sequences. Square summable sequences. So can you give an element? Yes, I can give an element. What is that? I can take like 1 by n. See, in this case, suppose I am going to take x is equals to 1, 1 by 2, 1 by 3 like this. Is it an element of L1? No. Understand? Why? Because I equals to 1 to infinity. Mod of xi is nothing but what? Summation I equals to 1 to infinity. Mod of 1 by I is nothing but summation I equals to 1 to infinity 1 by I. You know, by p-test it is divergent. Understand? It's not convergent. Right? Therefore, this x should not be a member of L1. Set of all 1 by n means what? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 is a sequence, but which is not an element of L1. Whereas set of all sequence, that the sequence of real numbers 1, 1 square, 1 by 2 square, 1 by 3 square, 1 by 4, like that, is always an element of L1. See here, suppose you take this x is equals to 1, 1 by 2, the same sequence. Is it an element of L2? Yes. Because it's an element of L2. Why? Because actually, look at this definition. Summation I equals to 1 to infinity. Modulus of xi whole square is exactly summation I equals to 1 to infinity. Xi means 1 by I square. This is a typical term. By p-test, it is convergent. Hence, it's an element of L2. So this is a definition of LP spaces. Right? This is a definition of LP spaces. Right? So the same strategy d1 of x comma y is equals to summation I equals to into infinity modulus of xi minus y. In previous same strategy by means cos inequality. So this is also metric. We have seen, right? Euclidean metric and 2 whole power 2, right? For x is equals to x1, x2, same strategy. LP, where p1 less than or equals to p less than infinity. So this is a metric on LP, right? D2 nothing but 1 comma y is equals to maximum, not maximum, supremum, because there are infinite many terms, we don't have a maximum. Supremum of mod of xi minus yi, where I belongs to it, is also metric. ఇంతకుముందు చదివాం కదా మాక్సిమం ఆఫ్, ఇక్కడ చదివాం గుర్తుంది కదా, సేమ్ ప్రూఫ్ నేను చేయట్లేనండి, సేమ్ ప్రూఫ్ ఇక్కడ చేసాను చూడండి. సుప్రీమం ఇక్కడ మ్యాక్సిమం తీసుకున్నాను, ఇక్కడ ఏం తీసుకున్నాను, సుప్రీమం తీసుకున్నాను, సేమ్ ప్రూఫ్ నేను చేయట్లేను. దెర్ఫోర్ దిస్ మెట్రిక్ which are metrics on LP spaces. Okay, so this is about LP, right? See, we are taking the element, ఇక్కడ చూడండి అమ్మా, we are taking P is an element lies between 1 to infinity. Why don't you take P from 0 to 1? Why don't you take P negative? Why don't you take P negative? This is the definition. This is a definition. Suppose you take the LP space ఇట్లా తీసుకొని ఇట్లా తీసుకోవచ్చా, P less than 1. Suppose distance between x and y is equals to summation I equals to 1 to infinity mod of xi minus yi whole power p whole power 1 by p అని తీసుకోవచ్చా? ఇది మెట్రిక్ అవుతుందా ఆన్ ఎల్పి మీద? ఇది అవుతుందమ్మా, ఇది మెట్రిక్ అవుతుందా? సో ఇది p లైస్ బిట్వీన్ 0 to 1 ఉన్నప్పుడు కాదు, ఎందుకంటే యాక్చువల్గా మీరు x is equals to 1 తీసుకోండి, 1 0 0 0 0 0 0, ఇన్ఫాక్ట్ r పవర్ n తీసుకోండి, ఇదంతా అవసరం కూడా లేదు, r పవర్ n